He knows a lot about the science stuff, Professor Dave explains.
Since the dawn of the space age in the middle of the 20th century, we've sent unmanned probes all over the solar system, which have given us some incredible images of the planets and moons that are part of our system. There are plans to send humans to Mars, and the Galilean moons of Jupiter shouldn't be too long after that. But as exciting as it will be to colonize our system, beyond Mars there are only a handful of moons that are even remotely fit for such an endeavor. Our search for habitable worlds will inevitably lead us outside of our own system. This poses a tremendous challenge because as far away as the other planets and moons in this system are, this distance is utterly insignificant compared to the vast distances to other stars. We will certainly need to innovate new methods of propulsion in order to get there in a reasonable amount of time. But we will achieve this, and when we do, where will we go first? The most logical destination once we achieve the capacity for interstellar travel will be the closest star to our own sun. So, which star is this? If we look to Centaurus, a constellation in the southern sky, we will find this closest star. Or technically not the single closest, but rather three stars that are extremely close together, which as a whole represent the system that is closest to our sun. This triple star system is called the Alpha Centauri system. The closest of these stars is called Proxima Centauri, named as such because of its proximity, and this star is almost certainly gravitationally bound to the other two, which are called Alpha Centauri A and Alpha Centauri B, which together form a binary system. So how far away are these nearest neighbors? They are farther than you think. The fastest probe we have ever built would take over 50,000 years to get there. Even light traveling at the universal speed limit would take more than 4 years to get there. Proxima Centauri is 4.23 light-years away, while the Alpha Centauri stars are 4.32 and 4.37 light-years away. But if we can invent new methods of propulsion, like fusion or solar sails, or some other incredible new technology, it's possible that we could get there within a human lifetime. So what will we find when we get there? Well, we would reach Proxima Centauri first. This is a dim red dwarf star, so it's very tiny and cool as far as stars go. Its mass is only 12% of our sun's, and its radius is around 15% of our sun's. It has one planet that we call Proxima Centauri b, which is therefore the closest exoplanet to us, or the closest planet outside of our solar system. It is roughly Earth-sized and has an orbital period of around 11 Earth days. Its orbital radius is around 0.05 astronomical units, or 5% of Earth's orbital radius. Even though it is so close, because the star is so much smaller and cooler than ours, Proxima Centauri b actually sits in the habitable zone of its star, which means it could harbor liquid water. Based on density calculations, it seems likely that it has a rocky surface, potentially with features that would be familiar to us, making it even more reasonable that this will be the first planet we set foot on outside of our solar system. The surface temperature depends on the rate of the planet's rotation. There are two models that seem most probable. Proxima Centauri b may rotate in 3:2 resonance with its star, which would allow for a relatively smooth distribution of heat from the star as the planet rotates. But the planet may also be tidally locked, exhibiting synchronous rotation, meaning that the same side always faces its star, like the way the same side of the moon always faces the Earth. This would make one side very bright and hot, and the other side very dark and cold. The habitability of the planet will depend greatly on which of these turns out to be correct. The atmosphere will also be a factor, and this will depend on the strength of the planet's magnetic field. The weaker the magnetic field is, the more likely it is that activity from its star will have stripped away the atmosphere. The stronger the magnetic field is, the more likely it is to have retained an atmosphere, despite stellar activity. We will continue to learn more about this planet in the coming decades. There is also some evidence of another planet named Proxima Centauri c that may orbit at 1.5 astronomical units, which is extremely far from its star relative to the orbit of Proxima Centauri b. However, more data will have to be gathered to verify its existence. Beyond this, there are two dust belts around the star, one at around 1 to 4 astronomical units and another at around 30. Together, these planets, one confirmed and one unconfirmed, and some accompanying features, make this quite an interesting system. If we were to continue from here, it wouldn't be too long before we reach Alpha Centauri A and B. As we said, these make up a binary star system, which means two stars that are quite close together, orbiting around their center of mass, in this particular case, once every 80 Earth years. Their orbit is elliptical, so the distance between them changes throughout the orbit, but on average, they are about as far apart as our Sun and its outermost planets. They are both very Sun-like, almost the same as our Sun in mass and size. It is possible that either of these stars has one or more planets, and it is even possible that there could be a planet orbiting the binary system as a whole. We do think it is highly likely that such a planet exists, but there is not yet sufficient evidence to conclude this. We will continue to study this system from here on Earth, as there is more data to gather, and hopefully later in this century we can send an unmanned probe in that direction if we can figure out how to get it going fast enough to make it worth our while. Perhaps if we can make it all the way there and get some more information, we can shed some light on the habitability of the planet or planets in this system. Could we ever colonize Proxima Centauri b? It is difficult to say because it is very close to Proxima Centauri, which is a flare star, so it is subjected to intense stellar wind, which means plumes of high-energy particles emitted by Proxima Centauri barrage the surface with 2,000 times greater intensity than our Sun sends to us here on Earth. This would make it difficult to live there, at least without protective habitats, and it also makes it pretty unlikely that we would find any existing life when we get there, as the radiation would kill any microscopic life we can conceive of. But we certainly don't know for sure, and we won't know for sure until we set foot there ourselves. Hopefully, we will unravel the secrets of the Alpha Centauri system one day, and perhaps there are even people that are already alive that will personally set foot on these worlds.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.